Hey guys, Mr. Jenkins back here with lesson 2 from chapter 5, and this is about polynomials, linear factors, and zeros. So kind of thinking about how all of that stuff ties together, which you should have some knowledge of from what we've covered with quadratics. So on that note, we will go ahead and look at an example. So if we look at the polynomial function, f of x equals x squared plus 2x minus 8, and there it is, kind of plugged into a graphing calculator, then then it's zeros from the graph. We can see remember that's zeros are your x-intercepts, where that's where y equals 0. So we can see that this crosses at 2, 0, and it looks like 1, 2, 3, so negative 4, 0. Okay, so graphically we can tell that those are my solutions. X equals negative 4 and x equals positive 2. Okay, so remember, just another way that we could get there if we needed to would be to factor this out, right? So we could say what's going to multiply to negative 8, add to positive 2, and that would be positive 4 and negative 2, okay? So, 4 times negative 2 is equal to that, and 4 plus negative 2 is equal to 2. Okay, so then we know this factors to x plus 4 times x minus 2. And then we can use the zero product property to come up with x is negative 4 and x is positive 2. Okay, so again, so my zeros, and we've shown how these things tie together, would be x equals negative 4 and x equals positive 2. All right, so it says finding the zeros of a polynomial function will help you factor the polynomial, graph the function, and solve the equation. So all of these things can be helpful, and they all relate to the zeros of the function, right? And remember, the value of the function is the y value, right, or the output value. So that's why we call any x-intercept, that would be a 0. That's where the value of the function is 0. All right, so anyways, it gives some just some mathematical rules right here. We'll basically summarize down here because this mathematical language, it can be confusing to me sometimes. So let's look at some regular examples. So it says, let p of x equal x to the 3 minus 2x minus 4, and let x equal 2. All right, so then it says, then p of 2 equals 0. So just so we know, what that means is, algebraically, if I sub in, well, I guess they're just telling me that one of our zeros is 2. But if I sub in 2 there and 2 there, I'm going to get 0. So it says p of 2 equals 0. So that tells me then what is a factor of that. All right. So a factor would be it's not going to be x plus 2. It's going to be x minus 2. Right? Because again, we think in terms of the zero product property. If I set this equal to 0, that would give me x equals 2. And x equals 2 is a 0. And then blank is a solution. So that also means that x equals 2 is a solution. Okay, so a lot of these words tie in together and mean the same thing. 0, solution. Some other words you're going to hear is root. Okay, so a lot of this stuff is just knowing your vocabulary terminology. And lastly, the point 2, 0 is an x-intercept. Okay, so we could have punched that into our graphing calculator, but they told us that. So we're just looking at how all these things tie together. All right, so we'll start on our examples with a review of some factoring, okay? So it just says factor the following polynomials completely, all right? And I'll probably just look at each one because they're just important. All right, so this one says x to the 3 plus 2x to the 2 minus 15x. So we have not factored any cubic trinomials, right? So what we'd want to do first here is factor out a GCF. So we'd want to rewrite this as x times the quantity x squared plus 2x minus 15. Then we have a DMR problem. So now we're thinking what multiplies to negative 15 adds to positive 2. So that's going to be 5 and negative 3. All right, so now as we factor further, well, another question would be like, why am I not done here? I know I'm not done because I have a nonlinear factor. X is a linear factor. X squared dot 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 is not a linear factor. So that's how I knew to keep going there. Anyways, my final answer would be x times the quantity, x plus 5, times the quantity, x minus 3. And again, like, why do I want to be able to do that? Because now I can quickly, without a graph or anything, look at this and tell you that my zeros are x equals 0, x equals negative 5, and x equals 3, just by using that zero product property. Okay? Looking at our next example, again, got to factor that GCF out first, which would give you x times the quantity x squared minus 49. And I'm going to kind of let you take it from there. So go ahead and tell me what the fully factored form of this of this cubic binomial is. It is not fully factored as I've left it. Okay, so hopefully what you came up with is, so that's a difference of squares. So that's going to be an a plus b times a minus b. So final answer, x times the quantity x plus 7 times the quantity x minus 7. All right, then our last one, going to be a little bit tougher because a is not equal to 1. So you know that's going to be a little bit tougher. First things first, we want to factor out our GCF. So rewrite it as x times the quantity 6x squared plus 5x plus 1. All right, so now we're thinking what is going to add to be 5 and multiply to be 6 times 1 is 6. All right, so adds to be 5, multiplies to be 6. That sounds like 3 and 2. So 3 times 2. So we will have to factor by grouping here. So this is going to take another step or two. So we go x times the quantity 6x squared plus 3x plus 2x plus 1. Now we factor by grouping. So I'm going to skip down to here. It's going to be x times the quantity, factor out a 3 from those. 3x. So 3x times, that'd be 2x plus 1. And then out of there, nothing, so a plus 1 times the quantity 2x plus 1. I know that looks a little confusing with all the parentheses, but final answer would be, don't forget your x, 3x plus 1. And 2x plus 1. And you know, this is a good reminder for those of you who just like to lean on your calculator and you know, saying I can just plug that into my calculator. It's going to be tough to come up with the 0 of negative 1/3 and negative 1/2 just by using your calculator. So factoring does play a role. Okay. All right, so now we're going to look at this on a more graphic kind of level. Okay, I'm going to skip down to B here. I'll leave A for you. Let me zoom out just a little bit. Okay, so it says, what are the zeros of y equals x minus 1 times x plus 4 times x minus 2? So at the top there, it also says to sketch a graph of this function. So to answer the easy part, my zeros would be, well, if I set that equal to 0, I get x equals 1. Set that equal to x plus 4 equals 0, tells me that x equals negative 4. And then my last one, x minus 2 equals 0, tells me that my last 0 is x equals 2. So I know that just because this is already in factored form, okay? Now, this is in the calculator for you already, all right? So the last thing that you would kind of take note of if you wanted to make a decent sketch, well, just based on the zeros, we know that, we'll say that's 0, negative 4. Then we have x equals 1. Sorry, I wrote that out wrong. That should say negative 4 comma 0. Then we have 1, 0, and then we have 2, 0. Okay, so the only thing you'd really need to look at the graphing calculator for would be like the end behavior, right? So this one is a down and up, right? So that would just tell you kind of how to fill in the gaps, right? So finishes or starts down. And finishes up, okay? And you wouldn't want that little change of direction like I did there. I just got a little sloppy, okay? But the big aspects that we care about most are these x-intercepts, aka zeros, okay? These are the x values where the value of the function equals 0. All right, so now we are going to start with the zeros and then write a function rule. Okay, so on these, I'm not sure you'll have to see how MathXL wants it, but this would be how you would start. So looking at A, it says our zeros are 4 and negative 4. That could also say x equals plus or minus 4. All right, so what's a function that gives me those zeros? All right, so you would start with, well, what's going to give me 4? That'd be x minus 4. What's going to give me negative 4? That'd be x plus 4. Now, if it wants linear factors, then you would be done there. You could just say f of x or y equals that. Okay, I think on MathXL what they're going to want is they're going to want you to simplify that, right? So you to FOIL that out. So that'd be x squared plus 4x minus 4x minus 16. All right, and so that is just x squared minus 16. So it just depends on which way they want it. It could be that, or it could be that. So just look at what are they looking for. Read the directions. Okay, let's do one that's just maybe a little bit tougher. So I'll leave C for you, and I'll do B. Yeah, let me do B, and then yeah, you can do C. Okay, so given the zeros, x equals 3, x equals 3, and x equals negative 4. Okay, so we'd have to start f of x is equal to x minus 3 squared, or x minus 3 times x minus 3 times x plus 4. All right, so there is a shortcut for this one, but you may need to multiply that out as x minus 3 times x minus 3. I know the shortcut, so I'm going to use that when I'm multiplying this first part. So it is x, or a squared, minus 2ab, so minus 3 times 2 times 6 would be minus 6x. Hopefully that'll pop up here in a second. Let's try that again. X squared minus 6x, and then plus b squared, so plus 9. I knew it was going to look like that. Sorry about that. Just edit that out. So x plus 3 squared, or sorry, x minus 3 squared, going to multiply to x squared minus 6x plus 9. And then we'd have that times x plus 4. So you see this is not a really easy problem, right? So now we'll have, a trinomial times a binomial. That would give you 6 terms, and then you'd have to clean that up. I'll go ahead and skip a step there and just give you the cleaned up version. So we'd end up with f of x is equal to x to the 3 minus 2x to the 2 minus 15x plus 36. And I go into more detail on the filled out notes if you need to see that. So these are not super easy problems, okay? But what's kind of neat about this is you could plug that into your graphing calculator and see, does it cross at x equals 3 and x equals negative 4. Okay, so our last kind of problem here is we're going to state the zeros. They give us our functions in factored form, and then we get into this idea of multiplicity. All right, so multiplicity is just for repeated zeros. All right, so anytime you see one like this, x minus 3 squared, that's gonna say 3 is a 0 with a multiplicity of 2. Okay, so I'll just do a couple of these. These are pretty easy once you get them. All right, so just going from left to right, x minus 4 to the 3rd power tells me that x equals 4 is one of my zeros, but it has a multiplicity of 3. You can't really see that on the graph, okay? It just is there, okay? So x equals 4 with a multiplicity of 3. Next one tells me that x equals negative 1. With a multiplicity of 2. And then lastly, x equals 2 with a multiplicity of 1, so we just say x equals 2. All right, so this is a big deal too. If I kind of wrote this out in standard form, just the fact that I have, this is 3 zeros right here, this is 2 more, so 5. And then that's another one. So I would have a 6th degree polynomial function if I multiplied all of this out. Okay, so if it is 6th degree, then you should have 6 zeros. Even though we only see 1, 2, 3 x-intercepts, there are actually 6 zeros because of these multiplicities. Okay, so I'll just do another one real quick. Just skip to D since we can kind of see that one. We'd have x equals 1, and that has a multiplicity of 2. And we have x equals negative 1 with a multiplicity of 2. Okay, so again, that'll show up here in a second. But again, if I multiplied this and this, I would get a term in there with my lead term would be x to the 4th, something x to the 4th. Okay, so just kind of getting into the idea of now, if we look at a polynomial function, we should at least be able to tell how many zeros it has by its degree. Okay, that's kind of a key idea of this chapter. All right, guys, hopefully this helps. If you guys need more help on the ones where we start with the linear factors, but then have to multiply all that out, just let me know and I can show more of those on the board. It's just not necessarily tough work. It's just a lot of, it's just kind of tedious, I guess would be a good word. Okay, but hopefully this helps and you guys have a nice day. Bye.